This is Miss Humbert here, and today we're going to be doing a little bit of the Pythagorean theorem. So this is Unit 8 Learning Target 11, talking about the Pythagorean theorem. So you've done the Pythagorean theorem before, probably in middle school. Now we're going to look at applying it to the work we've been doing with radicals. So let's go ahead and let's take a look. What is the Pythagorean theorem? So if you have a right triangle, what you can do is you can take the two legs of the right triangle. Notice that the legs of the right triangle actually touch the right triangle. So we take the two legs and square them, and then we add them. So a squared plus b squared is going to be equal to the hypotenuse squared. Now the hypotenuse is always going to sit opposite of that right angle. Okay, so let's just take a look at applying this, shall we? All right, so taking a look first at number 1. So for number 1, we have a is equal to 8 and b is equal to 15. So we can go ahead and both of these are going to be legs. So 8 squared plus 15 squared is equal to c squared. So that's 64 plus 225 is equal to c squared. So c squared is equal to 289. Well, I don't want to know what c squared is. I want to know what c is. So to undo that, you're going to take the square root of both sides. And actually, luckily enough for us, the square root of 289 is a whole number. So we don't even have to simplify the radical because 289 breaks down to 17 and 17. So the simplified radical is the square root, which is 17. Now, when it asks you for a decimal, that's a lot of times when we don't have a simplified radical. That's kind of like our estimate. But since it does simplify to be a whole number, our decimal is just 17. Next, taking a look at number 2. Those a and b are both our legs. So 18 squared plus, not plus b squared, plus 24 squared is equal to c squared. Well, 18 squared is 324, 24 squared is 576, and that's equal to c squared. So you get c squared is equal to 900. And then you're going to take the square root of both sides. Again, I happen to know that the square root of 900 is a whole number, and that's going to be 30. So that means when we get a perfect square, our whole number and our simplified radical are going to be the same. Now, taking a look at number 3, we have A and we have C. What we don't know is one of our legs. So what I have is 10 squared plus B squared is equal to 25 squared because I don't know what B is. So I get 100 plus B squared is equal to 625. So now what I'm going to have to do is I need to solve for B squared. So I need to get that 100 over to the other side. So I'm going to subtract 100 from both sides, and I end up getting that b squared is equal to 525. Now I just happen to know that 525 is not a perfect radical. So I need to take the square root of 525, right? Because that's how we get what just b is we take the square root. And I'm going to break down that radical. Well, I see that it ends in 25. That means it's divisible by 25. So I break it down to 25 and 21. Well, 25 breaks down to 5 and 5. 21 breaks down to 3 and 7. So then for our simplified radical, we end up having, I'm just going to give myself some more space here. We end up having the square root of 3 times 5 times 5 times 7. So I can take out a pair of 5s on the outside. And left underneath the radical is 3 times 7, which is 21. So our simplified radical is 5 times the square root of 21. Now, we need to get what that decimal is. So then, in my calculator, I'm actually going to type 5 times the square root of 21. And when I type that in, I end up getting 22.91. Remember to watch your rounding. If the third number is 5 or greater, you round up. If it's 4 or below, you round down. Now let's take a look at number 4. We know it's B and we know C. What we don't know is A. So A squared plus 11 squared is equal to 21 squared. So A squared plus 121 is equal to 441. Then what we want to do is subtract 121 from both sides, and we get A squared is equal to 320. So now we're going to take the square root of both sides. So we need to simplify down the square root of 320. Well, I see that it ends in 0, so I know it's divisible by 10. And then I can break it to 32. Well, 10 breaks down to 5 and 2. 32 breaks down to 8 and 4. 4 breaks down to 2 and 2. 8 breaks down to 4 and 2. And oops, undo. No, all my work. Okay, and then 4, and then 2 and 2. So I have 1 pair of 2s, 2 pair of 2s, and 3 pairs of 2s. So that's going to be 8 on the outside when I multiply all those pairs of 2s. And left underneath the radical is that 5. So I know it's kind of small, but that was me simplifying out the radical 320. So then 8 times the square root of 5, when you put that as a decimal, is 17.89. Now let's take a look at number 5. So for number 5, we need to do the Pythagorean theorem. Now here we know both the legs. So we have 6 squared plus 4 squared is equal to c squared. So then I get 36 plus 16 is equal to c squared. So then c squared is going to be equal to 52. So now to solve for c, I need to take the square root of both sides. So then I'm going to take a look at the square root of 52. And then I get 2 and 26, which can break down to 2 and 13. So I have a pair of 2's I can take out. So I'm going to have 2 times the square root of 13 as my simplified radical. So then I can go ahead and try and figure out my decimal. So what's 2 times the square root of 13? That's going to be 14.42. Next, taking a look at number 6. Again, I know my a and b. So 7 squared plus 10 squared is equal to c squared. So 49 plus 100 is equal to c squared. And then I get that c squared is equal to 149. So to get rid of the squared on the c, I'm going to take the square root of both sides. So I went through and I tried to find pairs for that. But there are no pairs under the square root of 149. So the simplified radical is actually 149. So you take the square root of 149 to get your approximated decimal. So that distance is about 12.07. And we do that approximated decimal so we can kind of get an estimate for that distance. All right, let's take a look at number 7. So for number 7, we want to find this missing side. So I noticed that the missing side is the hypotenuse, or our c. So then we're going to do 4 squared plus 8 squared is equal to c squared. So then I get 16 plus 64 is equal to c squared. So I get that c squared is equal to 80. So to get what c is, I need to take the square root of both sides. So now I'm going to go ahead and I'm going to take the square root of 80. So then when I simplify out that radical, I get 8 and 10, which is 4 and 2. Give myself some more space here. As well as 2 and 2, and this is 5 and 2. Let me please. 5 and 2, and this is 2 and 2. So I have 1 pair of 2's, 2 pair of 2's. So I'm going to multiply those on the outside. Again, I'm simplifying the radicals through pretty quickly because I'm hoping that's something you're comfortable with by now. So then I get 4 square root of 5 for number 7. Then taking a look at number 8. Again, I'm missing that hypotenuse side, so that's my c. So I have 3 squared plus 6 squared is equal to c squared. So then I get 9 plus 36 is equal to c squared. So c squared is equal to 45. So now to just get c, I need to take the square root of both sides. So I get that c is equal to the square root of 45. Now I need to break that down. And then we do 9 and 5, and then 3 and 3. So I can take out a pair of 3's. So I take out the pair of 3's on the outside, and then I'm left with 5 underneath. So c is equal to 3 times the square root of 5. So let's take a look at number 9. So for number 9, what we want to do is we want to figure out what one of our legs is. One of our legs is missing, so let's just call that b. So 4 squared plus b squared is equal to 9 squared. It doesn't matter if you assign the missing leg to be a or b. You can decide. So 4 squared is 16 plus b squared is equal to 81. So then we're going to go ahead and subtract 16 from both sides, and you end up getting that x squared is equal to the square root of 65 when you take the square root to get your x. So x is equal to the square root of 65. Well, let's go ahead and let's try and break that down. So I divide it by 5, and I end up getting 13. Both of those are prime numbers, so I don't have a pair. So my final answer is just x is equal to the square root of 65. Taking a look at this one, we're still missing that side. So then we're going to have 4 squared plus x squared or b squared. It doesn't matter what letter, you just need to know that this right here is a leg, so it needs to be on the side with the sum. So then I get 16 plus x squared is equal to 196. So then I'm going to subtract 16 from both sides, and I get x squared is equal to 180. So then what I want to do is I want to take the square root of each side, and I get x is equal to the square root of 180. So we're going to divide this up, and I see that it ends in a 0, so I'm going to split it up to be 18 and 10. 18 I can divide down to 9 and 2. 9 I can break down to 3 and 3. 10 I can break down to 5 and 2. So I have 1 pairs of 3s and 1 pairs of 2s. 3 times 2 is 6 on the outside, and then left underneath the radical without a pair is a 5. So if you still need to go through and write it out like this, like we've been doing, please feel free to do that if that helps you, okay? There's no need to try and do it like I'm doing that if that's confusing for you. So let's take a look now at number 11. So for number 11, we have the Pythagorean theorem. We want to use it to find our diagonal. Well, here's what you should know about a rectangle, is that it has a right angle. So our missing length is our hypotenuse. So 5 squared plus 12 squared is equal to our hypotenuse squared, which we don't know, so I used x. So then we have 25, or not, 25 plus 144 is equal to x squared. So then I get that x squared is equal to 169. So now to get rid of the x squared, I need to take the square root of both sides. And then we have x is equal to, well, the square root of 169 is 13. That's actually a whole number. But you'll notice that I have labels in these problems, so I better have a label on my answer. So the diagonal of that rectangle is 13 centimeters. Next, let's take a look at this one. Use the Pythagorean theorem to calculate the radius. So this right here is a right angle. So we have 2 legs with 4 centimeters. Our unknown, our radius, is the hypotenuse of that right triangle. So then I end up getting 16 plus 16 is equal to r squared. So I end up getting that r squared is equal to 32. So I'm going to go ahead and take the square root of both sides. So r is equal to the square root of 32. And then you're going to break that down. You're going to break it down into, let's use 8 and 4 actually. 8 and 4. And 8 we can break down to 4 and 2. 4 we can break down to 2 and 2. 4 we can break down to 2 and 2. So I have 2 pairs of 2's. So when you multiply 2 times 2 on the outside, you get 4. And then left without a partner underneath the radical is that 2. So you get 4 square root of 2. Now I just need to check my label from the original problem, and that is centimeters. So that concludes your note video for today. Go ahead and show me your completed note sheet when you are done. Thanks for listening.